Hello student, in this video lecture we are going to study the cumulant generating function of negative binomial distribution, central moments of negative binomial distribution, coefficient of cueness and coefficient of kurtosis of negative binomial distribution. Now first we see the cumulant generating function of negative binomial distribution. Okay. Now if random variable x follows negative binomial distribution with parameters k and p, then its moment generating function is MGF moment generating function is given by mx of t is equal to q minus capital P into in bracket e raised to t minus 1 bracket complete square bracket complete bracket raised to minus k. Here capital Q is equal to 1 upon P and capital P is equal to Q upon P. Okay, now if we substitute the values of capital Q and capital P, then we have this is 1 upon P minus Q upon P into in bracket 1 minus in bracket e raised to t minus 1 bracket complete bracket raised to minus k. Okay, then this is MGF of random variable x, and that random variable x follows the negative binomial distribution. Then again we know that this q minus p is equal to 1. Okay, now in the above form of MGF, this form now becomes q minus p plus p minus p into in bracket e raised to t minus 1 bracket complete raised to minus k. Means here we subtract capital P and we add capital P in this form. This form remains the same. Now we know that q minus p is equal to 1. That is, this is q minus p. Now we put q minus p is equal to 1. Then we have this is 1 plus. Okay. P minus p into in bracket e raised to t. Okay, this raised to minus k. Here is only e raised to t. Okay, here is only e raised to t. Now from these two terms 1 minus p into in bracket e raised to t minus 1 bracket complete bracket raised to minus k. Minus p is taken common from these two terms. Okay, again here this form it's this one. Okay, now this is moment generating function of negative binomial distribution. Now we obtain cumulant generating function of negative binomial distribution. Kx of t is the notation for cumulant generating function, and which is equal to log 2 base e of moment generating function, log of mgf. Now we substitute the value of mgf here, which is equal to log 2 base e of 1 minus p into in bracket e raised to t minus 1 bracket raised to minus k. Now this which is equal to minus k into in bracket 1 minus p into in bracket e raised to t minus 1 bracket complete square bracket complete k x of t. Okay, then again here e raised to t equal to 1 plus t plus t square upon 2 factorial plus t cube upon 3 factorial plus so on, and e raised to t minus 1 is equal to, this is equal to t plus t square upon 2 factorial plus t cube upon 3 factorial plus dash 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 dash. Okay, then kx of t is equal to kx of t is equal to k into in bracket 1 minus a. Here a is equal to capital P into in bracket e raised to t minus 1. Okay, then this is equal to minus k into log 2 base e, then here is k into log of 1 minus a to base e. Then we know that log of 1 minus x is equal to minus in bracket x plus x square by 2 plus x cube by 3 plus so on. Log of 1 minus x is equal to minus into in bracket x plus x square by 2 plus x cube by 3 plus so on. Now we use this formula in the above kx of t, k into log of 1 minus a, here a is equal to capital P into in bracket e raised to t minus 1. Therefore here is negative sign. Okay, then kx of t is equal to, we substitute here, we use this formula here, and which is equal to k into in bracket a plus a square by 2 plus a cube by 3 plus dash dash dash. Okay, now substitute value of a here, Then kx of t is equal to k into in bracket, first term is what? Capital P into in bracket e raised to t is equal to this one, t plus t square upon 2 factorial plus t cube upon 3 factorial plus dash dash dash, this bracket complete. Then plus second term a square by 2, it is equal to p square into bracket t plus t square upon 2 factorial plus t cube upon 3 factorial plus dash dash dash, bracket complete, brackets are square, plus p square by 2 here, then p cube upon 3 into bracket t plus t square upon 2 factorial plus t cube upon 3 factorial plus dash dash dash, bracket complete, brackets are cube, then plus p raised to 4 upon 4 into bracket t plus t square upon 2 factorial plus t cube upon 3 factorial plus dash dash dash, bracket complete, bracket raised to 4 plus dash dash dash, this square bracket complete here. Okay, this is the expansion for kx of t. Okay, then by using this expansion we can obtain the cumulants of random variable x, that is cumulants of negative binomial distribution. Okay, now we know that is k1 is equal to first cumulants, and which is equal to what? Coefficient of t in kx of t. We take the coefficient of t, and that is the first cumulants k1, and we know that k1 is equal to coefficient of t is equal to only k into capital P, then which is equal to kq upon p, which is the mean of negative binomial distribution. Capital P is equal to q upon p. Okay, then k2 is equal to second cumulants of negative binomial distribution is coefficient of t square upon 2 factorial in kx of t, and which is equal to kq upon p square, k2. Then k3 is equal to coefficient of t raised to 3 upon 3 factorial in kx of t in the expansion of cumulant generating function. Then this k3 is equal to kpq into bracket q plus p, and k4 is equal to coefficient of t raised to 4 upon 4 factorial in the expansion of kx of t. Then we have k4 is equal to kpq into in bracket 1 plus 6 into pq. This is the first 4 cumulants of negative binomial distribution. Now we see the relation between cumulants and central moments, that is we obtain central moments using cumulants. Okay, then we know that this mu1 dash is equal to k1, which is equal to kq upon p. Then mu2 is equal to k2. Second order central moment is equal to the second order cumulants. Mu2 is equal to k2, which is equal to kq upon p square, and mu3 is equal to third order central moment is equal to k3, which is equal to kpq into in bracket q plus p. Okay, now we substitute here capital P and capital Q. That is, capital P is equal to q upon p and capital Q is equal to 1 upon p. Okay, which is equal to k into q upon p square into in bracket 1 upon p plus q upon p. Okay, and which is equal to kq upon p square into in bracket, this is 1 plus q upon p. Okay, then now we obtain the mu4. Mu4 is equal to k4 plus 3 into k2 square. That is, mu4 is equal to kpq into in bracket 1 plus 6 into pq plus 3 into k2 square means kq upon p square bracket raised to the square. Okay, therefore mu4 is equal to kq upon p square into in bracket 1 plus 6 into pq, that is q upon p square plus 3 into k square into q square upon p raised to 4, again which is equal to kq upon p raised to 4 into in bracket p square plus 6 into q plus 3 into k square into q square upon p raised to 4. Okay, again which is equal to k into q upon p raised to 4 into in bracket p square plus 6 into q plus 3 into k into q. This bracket complete. Again which is equal to k into q upon p raised to 4 into in bracket p square plus 3 into q, or here is 3 into in bracket 2q plus 3q. Okay, this is the value of mu4, fourth order central moment of negative binomial distribution. Okay,